Hi everyone, in this series of inequalities and number line, today we are looking at absolute inequalities. And in our previous videos, we discussed a lot about inequalities and number line. If you have not watched those videos, the links are right away in the description of this video. So you can also go ahead and familiarize yourself before you continue with these absolute inequalities. But remember to come back and continue with the video. So we have a question here that talks about this opening bar and closing bar of certain thing inside that looks somehow intimidating, right? So in this video, I'm going to break it down step by step until you really get comfortable with it. So stick around up to the end of this video because we have 4 good examples to work around to know this concept ranging from linear to fractional absolute inequalities, so you don't miss out the last number that is very interesting. So please stick around. Now, looking at these inequalities, what is the meaning of absolute inequality exactly? So when we talk about absolute inequality, we look at this number could be a single number or double numbers inside these bars. They are how far are these numbers inside here from 0. So we have boundaries here 4, and the next number, which is a boundary also, will be -4. So how far is this from 0? So those are the concepts we need to mark here. Now we have 2 approaches. The first one is we have to just get what is inside these bars, and that is 3x minus 2. Then we get our inequality sign. For our case here is greater than or equals to 4. Now the second inequality we can write from this absolute, from the definition I've just mentioned, is we also write what is inside here, and that is 3x minus 2. This time we will reverse the sign and we have less than or equals to. Then the number here, or this constant, we reverse the sign from positive to -4. So that is the first approach. Or the second approach is we would also bring -4 to this side, remove these bars, while maintaining the same sign on 2 sides. How does this look like? This one is, we'll have -4. The sign here is greater than or equals to what is inside the bars, 3x minus 2. Then we also maintain the same sign, and we have 4. So this one at least looks somehow familiar because we discussed it in our previous video. And from there you can split these inequalities into 2 simpler ones, and from there you go ahead and work them out. So which method do you think is better for you? You can select and continue, but for now let me use this method, the first approach here. So let's solve the first small inequality from the left, and that is this. So we can collect like terms. So we have here 3x is greater than or equals to 4 plus 2. This one summing up to 6, dividing both sides by 3. We'll obtain 6 by 3, that is 2. Therefore our x is greater than or equals to 2. But for easy graphing on a number line, it is good when we write it this way: 2 is less than or equals to x. Just look at this open part here is facing x. Now when you bring x to the other side, also this should be facing this side also, such that it looks exactly like what we had here. So x is greater than or equals to 2 is the same like 2 is less than or equals to x. Now we will see what I'll be graphing it on a number line. Let's again work on this one. So here we have 3x, collecting like terms, we have here 4 plus 2, then 3x will be less than or equals to, this simplifies to negative 2. Again, dividing both sides by 3, so negative 2 is divided by 3. Therefore, x is less than or equals to negative 2/3. Now, having written this, we are good to go to represent this on a number line. Let's grab our ruler. Maybe pick it somewhere here. Maybe let's go a little bit up and draw. So we have this. Okay. So here we need to have 0 somewhere. Now, and we have to also locate these numbers on a number line. Like if we have here 1, then we have here 2, we can say 3 and 4. So these numbers are continuing to the infinity, the right hand side. Now the next one here is negative 1, negative 2, negative 3, and so on. Also, they are continuing to the negative infinity. So what we have to do here is, we know that if you divide negative 2 by 3 in a calculator, you get 0.6 recurring. So 0.6 is between negative 1 and 0. So this negative 0.6, if you run to one decimal place, just is negative 0.7, which is close to 1, somewhere here. Now we can draw a circle on it, somewhere there, and then we look at the solution. We have x that are less than this number, so numbers that integers that are less than negative 2 over 3 are to the left. So this one exactly, we have negative 2 over 3. So we can draw a line that is to the left. There are many integers to the left up to infinity. So here we have x is less than or equals to negative 2 over 3. Now let's do the same to the next number here, that is 2, and 2 is somewhere here. And from here we see that x are the numbers that are bigger than 2 to the right. So all numbers to the right of this equation to the right of these inequalities are the solutions for the second part. So we have x is greater than or equals to 2. Now before we pen off, remember we have less than or equals to. So this one means these circles are shaded, meaning the numbers are included. 2 is inclusive and negative 2 over 3 is also inclusive. So how do you represent the solution? So the solution is from negative infinity, comma, up to negative 2 over 3. But because of this shaded region here, we can close this and we would say union. Then the next solution here is we're starting from 2, so we'll start with this positive 2 comma the solution is up to infinite. So we have this, and we close also with the parentheses. To the right and to the left are all parentheses. Simply we have as many numbers as possible to the left, the same to the right, as many numbers as possible to the right. Now this is the solution for our inequality number 1, which is the absolute one. Are you enjoying the video? If yes, please leave a comment in the section here and see which method you prefer from the first approach I just told you. So next, let's look at the second part, that is B. And B, we have inequality like x plus 4 is greater than 6. So also let's work this one together and we'll see how the solution looks like. Looking at approach number 1, we can write what is inside the bars. X plus 4 is greater than 6, or x plus 4 is less than, and remember we change the sign from positive to negative. Then let's solve this inequality. Now collecting like terms, we'll have minus 4 is greater than 6 minus 4. Then our x is greater than 2. And again, we can write this one as 2 is less than x for easy graphing. Now we do the same to the second one. We have x minus 4, plus 4 minus 4 is less than negative 6 minus 4. So here x is less than negative 10. So let's pick our ruler and we draw the number line. So let me have my 0 somewhere here, because negative 10 would be somewhere far from 0 as compared to positive 2, which would be somewhere here. Now we have many numbers to the right and also some numbers to the left. So looking at this, we can get our inequalities. Let's start with the smallest one here, from 0 up to negative 10. We have x values that are less than negative 10, and this is to the right. Now this time we have less than sign, meaning we have an open circle. Then the next one here, we have x values that are more than 2. So this becomes a circle that is also open because of the sign, as we can see, and all integers to the right of 2 will give us possible solution. So we have that to the right, and here of course we have 2 is less than x. Meanwhile, x is less than negative 10. What is our solution? So from here we can see we start with negative infinity up to 10, and this time 10 is not inclusive, so we use open and close parentheses, and this is union. The next on this side is starting from 2. Since it's not also inclusive, we use open parentheses, 2 over to infinity, and also close with the same. That becomes our solution. So please, if you're enjoying the video, give it a thumbs up to push it to many audience. let's proceed to the next part C of the question that talks about 2 over 3x minus 1/4 is greater than 5. Now, if you get such kind of inequalities, what do? So don't panic. When you get the fractional inequalities, it's just similar to fractional equations. What we have to do is we will write this in that form without this bars, and then we get rid of these denominators off. So let's get started, and we have this as 2 that x minus 1/4 is greater than 5, or 2 that x minus quarter should be less than negative 5. So having looked at this, we'll get the LCM of 3 and 4. So that is 12. We multiply 12 by the left hand side, and we also multiply to the right hand side. So that is also 12. Now here we have our 2 that x minus 1 over 4 is greater than 5 times 12. So you notice that if you open up this bracket, you multiply 12 with 2 over 3, this will vanish to 1, and this one becomes 4. So we shall have here 4 times 2, we get 8. So here we have 8x. Now 12 times 1/4, it goes to 3. So we have minus 3 is greater than 5 by 12 is 60. So looking this again, we have our 8x minus 3 plus 3 is greater than 60 plus 3, and 8x is greater than 63. Dividing both sides by 8, our x would be, let's make it in decimals, so 63 divided by 8 gives us 7.9 to 1 decimal place. Then we also solve this by multiplying this by 12. So here by 12, filling in our gap here, we have 2 over 3x minus 1/4 is less than negative 5 times 12, sorry, not 15 but 12. So let's erase off this and we'll replace it by 2. So this 5 is being replaced by 2. Now, dividing 12 by 3, we get 4. 4 times 2 is also 8. So we have here 8x. Then this goes to negative 3. It's less than, and this is negative 60. So collecting like terms again, our 8x minus 3 plus 3 is less than negative 60 plus 3. So this one cancels, and we have 8x is less than, so this will reduce it to negative 57. Dividing both sides by 8, then our x here will be, let's enter it for a calculator and say negative 57 by 8 goes to negative 7.1. It also 1 decimal place. So as before, we can denote even this one as 7.9 is less than x. So that drawing it on a number line becomes quite simpler. So let's get our ruler and grab this on the number line. Now we're looking at 0, maybe in the middle, and then positive 7 would be somewhere here. So we have 7.9, then we have negative 7.1 on the left of 0, and this to the right of 0. So starting with the smallest one here, we can use our circle. Maybe let's use a different color and say this is our circle. So we have numbers that are less than negative 7.1. They are to the left. Then here we need numbers that are greater than 7.9. They are also to this side here. So we have x. Okay, let's start with this 7.9 is less than x, and here we have x is less than negative 7.1. So again, as before, this side will have from negative infinity, comma, to negative 7.1, and we close with this sign of parentheses because we have less than sign. If it would be less than or equals to, then we close just like in our previous example. Now here we're starting from 7.9 up to positive infinity, and in the middle here we have our union to solve the solution. So that becomes our solution. And lastly, let's move to part D of the question. In part D of the question, we have 4 minus 2 into 2x plus 1 is less than 5. So how do you solve this number? In this inequality, our main goal here is to make sure that the absolute value is isolated. So we have to get rid of 4 and negative 2 attached to this absolute value. So let's do that by subtracting 4 from both sides. So we have here 4 minus 4 minus 2 into 2x plus 1 is less than 5 minus 4. So the 4 disappears and we have 2, negative 2 into x plus into 2x plus 1 is less than positive 1. So we have to divide both sides by negative 2. But remember, when you're dividing inequality by a negative value, the inequality sign changes. So we have here by negative 2. So we're left with absolute value of 2x plus 1 is greater than negative 1/2. So here we can move on and write our two simpler inequalities. The first one being 2x plus 1 is greater than negative 1/2, or 2x plus 1 is less than, and reverse the sign from negative to positive, so we have here 1/2. Solving them independently, so the best one here is we need to multiply both sides this inequality by 2 to get rid of this fraction. So the right hand side would be negative 1/2 times 2, and of course the 2 will vanish off, and we open up this bracket to have 4x plus 2 is greater than negative 1. Also collecting like terms, we have negative 1 minus 2. So 4x is greater than negative 3. Dividing both sides by 4, we have negative 3 over 4. Or we can rewrite it as negative 3 over 4 is less than x. So solving the next one, we do the same way, multiplying both sides of this inequality by 2. We also have 1/2 from the right side multiplied by 2, and this one goes to 1. Opening up the bracket, we have 4x plus 2 is less than 1. Then collecting like terms, we have 4x is less than 1 minus 2. So that simplifies to negative 1. Dividing it by 4, so our x is less than negative 1 over 4. So these are the possible solutions for these two simpler inequalities. Now lastly, we're left with presenting them in a number line. So from our number line, we can draw a line, and we spot our 0. So this time all these numbers are negative. We can start with our 0 somewhere here towards the right, because we have the numbers here negative. So let's have the first one here, and that is negative 1/4. 3/4 is less than this, so it will be somewhere here. Maybe let me extend it somewhere, and we have negative 3/4, and this extends to negative infinity. So let's again use two colors to represent the first one here. So we need integers that are greater than negative 3/4. So all numbers on this side are greater than 3/4. So we can draw line to the right, and there's so many that we cannot finish them all, so we can use this arrow. Now let's do the same to the next. From here we'll have another arrow that is pointing to x is less than negative 3. So all numbers to the left of negative 1/4 to give us the solution for the second part. And you can see this is quite unique from the other 3 examples we look at, and that is the reason that I told you to stick up to the end of this video to see this interesting unique solution. So what happened when you study this pink solution was just drawn here? It passes this point. This means this point is also part of the solution. Likewise, the green line passes through this point. So finally, this is inclusive, this point here. So we have to do some shading. Though we have here less than or equals to, because of the point that is satisfying a green line, this one is shaded, and because of this point that is satisfying the pink line, this is also shaded, the green one. Now we do that. Now literally it means here that all these points from left and right of 0 satisfy these inequalities. that we have given earlier on up there. So for that case, our solution becomes, we're starting from negative infinity, comma, to positive infinity, and we close using the parentheses because the end is to the right, the same to the left. If you have watched up to this time, thank you very much for supporting this channel by watching this video. Please push it to large audience by liking and share with friends. See you in the next one, where we shall be discussing about graphing inequalities on a real graph, and where we shade out reasons that are not wanted to see the feasible reasons that can satisfy a given set of inequality. See you in the other side. Ciao.